Hello everyone, welcome to MathLAB programming course. Today we're going to start a new chapter which is really important, and I would like to say that from today on we're really into programming, and the concepts that we will learn from today you will frequently see in every MathLAB program around you. It is vital that we completely understand these parts and their functionality. We're going to cover a lot of examples on these stuff. The chapters that we already learned are going to serve us very well during these two coming chapters on vectors and matrices. I would like to start by letting you know that MathLAB name also came from Matrix Laboratory, which indicates how fundamental the matrices and vectors are to MathLAB programming, and it constitutes a great part of MathLAB syntax. So let's get started. Vectors are the first identity that we're going to cover today, and they're really important because once we learn how to deal with vectors, it's going to be very easy to extend what you learned and implement it on matrices as well. Therefore, you are basically learning matrices and vectors at the same time. So what is a vector? As we learned before, we can define a number and put it to a, like a this one, or b equals to -3. But there are occasions that you would like to associate two or more numbers to a single variable. For example, I would like to say c equals for example, I'm calculating the speed of a car as an example. So what is important in our physics problem is that we need to know the distance, we need to know the time, we need to know a speed, acceleration, speed of wind, and stuff like that. You know, there are a lot of factors and parameters that are associated with our problem. And let's imagine it this way. Let me clear up the screen. We have three cars that are going to compete with each other. So the first car, I call it A. And what are the important things? I wanted to compare the first car speed to the second car speed to the third car speed. And the same with acceleration of the first car to the second car and to the third one. It will be very hard if I wanted to introduce different variables for a speed of the first car, then velocity of the first car, then the acceleration of the first car. You know, it's going to be very hard to maintain the consistency of the program and just to remember what variable was that. Therefore, the vectors come into play. The way that we're going to define the vectors is using brackets. So if I say A, open bracket, and then I put 1, then space, 2, space, 3, any number, okay? So you can extend it to as long as you want. But let's keep things simple, so when we understand it completely, we can work on the other parts as well. I close the bracket, and if I hit enter, you will see that now A contains 3 numbers and not a single one. And this is something new that we learned today. Imagine that the first one is the distance, the second one is the velocity, and the third one is the acceleration of the first car. Now, if I say B equals 1, 4, and 7, close parentheses. Oh, sorry, I forgot to put equal sign. So if I do that, now B is like that, and I can introduce C as 3 and 1. I just put numbers in it that doesn't make sense in some cases, but it's not important. The point here is I can now associate 9 different values, 9 identities to 3 vectors and just do the calculations. And now it's much easier to understand that we're talking about the speed of the car C. So we definitely go to this item. Now we're going to talk about the distance in car A. So we go to this item. And this is the core concept behind the use of vectors. And let me clear up the screen. Another important point while using vectors, these are all the basics, by the way, and we get hang of it as we solve some problems on it. The other important thing that I would like to say that, for example, if I define a new variable, which is in kind of vectors, you're not limited to 3 items, because we conveniently define 3 as to be associated with XYZ, but literally you can go, as you like. There is no limit for you. One way to do vectors is like doing this, right? The same result. I would like to say that you can also put comma between, comma 2, comma 3, comma 4. And you would see that the same result appears. I did that example because there are some textbooks that prefer to put with comma and the other ones not with the comma, just with the space. And so you can do that as well. It is, however, different when we put A equals 1 semicolon 2 semicolon 3. I did that thing the same as above, but now let me add one more to make it like the one above. But here, as you see, I use semicolon instead of comma. So if I do that and hit enter, you will notice that now my vector is vertical. It's not horizontal. And it's really a fundamental concept in vectors and matrices. And we should learn that very, very well, because once we come to matrices and they're going to be algebraic calculations, they're going to be multiplications of the matrices, and it's just a very, very crucial point. Now there are other important parts that I want to emphasize here. So let me clear up the screen. And we have defined variable b, which has 3 parts. Now imagine that it's a vector. You wanted to convert this horizontal vector into a vertical vector. So instead of just retyping it into with the semicolons, what you can do is put b and single quotation mark. And if you do that, hit enter, it automatically changes the horizontal part into a vertical part. And if I repeat the same thing again, answer, it's gonna bring back the same result. Now we have B again. And it's very, very important. Another point which is worth mentioning is, do you remember the car, not this one, let's define it again. 1, 2, 3, 4. Okay. As you remember, and this was the example of the car that we just explored, and this was like the velocity. Of course, it was 3 items. It doesn't matter. So 1, 2, 3, 4. It's a new vector. It represents some variables. So this might be distance, velocity, acceleration, and the speed of the wind, for example. And now someone tells you, okay, now I am specifically interested in the velocity of the car A. Could you give me that? One way is, so you look at it and say, okay, it was a second item, so 1, 2, it is 2. But what if I wanted to extract it and do some calculation on it? I do have like 10 cars and I want to compare only the speed of these cars together. So what we can do is to extract each car's speed and then compare them together, or do some statistical analysis on them. The way that we can extract an item out of a vector is to type the name of the vector and open parentheses, 2 close parentheses. So what it's gonna do is going to extract the second item of this vector, which here it happens to be 2. So let me make a better example just to make it clear, like 3, -1, 7, 9, 10, 4, -12. So I do have 1, 2, 3, 4, 5, 6, and 7. I do have 7 items in my vector, which is like that. And then someone tells you, I'm interested in your 4th item. So I would say B4. What it does, it extracts the 4th item out of my vector, 1, 2, 3, and 4. How about then the 6th item? So it's gonna be 1, 2, 3, 4, 5, 6. It extracts the 6. That's simple. I would kind of encourage you to do some examples on it and just explore different possibilities and transpose it. Like this, we call it transpose, right? So we convert it into vertical format or vice versa. So I encourage you to do some examples on it and explore it so you can fully understand it. And again, I would like to emphasize it more that it is vital for matrix calculations. See you in next part.